I'm just videoing it. See, like right now.
Make sure you subscribe and hit that notification bell to stay tuned when I upload.
All right. So again, we're going to go over the homework question by question. I will show questions 6 and 15. Does that sound good? I'm going to walk through step by step questions 6 and 15. Sound good?
Yes.
All right. So it would be good if you had your calculators out, just in case something wasn't matching. You could quickly do this along with me. I have the problem screenshotted right up there as well. Okie dokie. Here we go. So this first problem is about hummingbirds, right? Hummingbird wing beat rates are much higher than those in other birds because they look like they're hovering in midair, right? Estimates for various species are given in the table provided. We've got masses along the top and then wing beats per second along the bottom. So I've got my x value is going to be the mass and my y value is going to be the wing beat per second. All right, so first thing I want to do is make a scatter plot. I'm going to go into my calculator and I am going to stat. Remember, stat is right there. Edit. And remember that I'm going to clear out everything that's there. Don't delete. You go up to list 1, clear, down. Go up to list 2, clear, down. And now I'm ready to input all of my stuff. So I'm going to come over here. I'm going to do that real quick. 1, 2. And then I'm going to do my y values. I messed up. Hold on. 55. Okay, I even do this when I'm making the keys for stuff. I cross-check just a couple of data points, like 4.5, 40, good. 2, 85, good. 3.7, 55. Okay, if I got a couple of them right, I probably did pretty okay. If you're on your quiz or test, check all of your data to make sure you punch them in. I would hate for you to miss points just because, you mistyped. All right, make a scatter plot. So for this, you go into y equals, clear out everything that's there. Make sure that your plot is highlighted. Your plot 1 is highlighted. And then you want to, now, I like to zoom 6 my graph before I do zoom stat. I don't know if that does anything. I just like to clear it, like to reset it before I do anything. So I always zoom standard, Z standard, put it to its 10 by 10, and now do zoom stat. I don't know if that helps anything. I know it makes a difference when you do zoom fit, that last one there. So I just like to kind of reset my window before I get started. Okay, so to reset the window, you do zoom 6, zoom standard, puts it to a 10 by 10. Now to make it fit the data, you do zoom, and then choice 9 for me is zoom stat. And there it is. Next thing I want to do, okay, so yeah, again, this says make a scatter plot. And remember what I said, if it ever asks you to make a scatter plot, I am okay with you just doing it on your calculator. Sketch what you see on your paper though. All right, now find the correlation coefficient in the line of best fit. So I go back out to my home screen. Again, if you didn't catch that, going back to your home screen, you always hit second quit. That mode button above mode is quit. So second quit will get you back to your home base, your home screen. So now to run the equation, you do stat, scroll right once to calc, and then choice 4 is linear regression. Choice 4 is linear regression. All right, so there is my regression. Now, for the folks playing along at home, I am going to put this on the whiteboard. Sorry.
Yeah,
As long as I can find my marker. Where's that blue marker? Did you take my blue marker? Did you take my blue marker?
Of course not. The what's behind your back?
I see. Of course. Here's a green one. This is a good one too. All right. So my R value, negative 0.9607. Pretty good R value, right? I can tell two things from that R value. The fact that it's negative tells me what? What does the fact that it's negative tell me? Oh, come on, we know this. What does the fact that it's negative tell me? A negative slope, good. It's a negative sloping line. And if it's really close to negative 0.1, or sorry, negative 1, excuse me, not negative 0.1, negative 1, then it's actually a pretty strong correlation, right? Based on this set of data, this model, this y is equal to negative 19.1434x plus 121.973, 0. That model fits that data pretty well. Okay, now let's get it on my scatter plot. Let's get that line on my scatter plot. So you go to your y equals. Remember, you always start with your y equals in this step. A lot of people forget to start with your y equals. Start in your y equals, and now you have to put in your equation. To do that, you go vars, right there. Choice 5 is statistics. And then scroll right twice to get to reg EQ, regression equation. And there's your question, or there's your equation. Okay, graph, and you should see the line come through the points. All right, so now I have my graph on, my line on my scatter plot. It then says predict the wing beat rate for a giant hummingbird, mass of 19 grams. Holy cow, that's a big hummingbird. Like, look at all our data. The highest we have is 4.
It's like the size of people.
This was 19. 19 grams. That is one giant hummingbird.
That's a big Texan hummingbird.
Now, when I go to calculate it, watch what happens. Second, now, why am I just going second calculate? Because what is 19 grams? Is that an X value or a Y value? I'm giving you an X value and asking you to find a Y value. When I give you an X value to plug in, you just go second calculate value. Value of 19. Here's the issue. 19 is not on my window. You know, Mrs. Napoltz teaches her students to manipulate the window. I say zoom out, but she actually teaches them to manipulate the window. So I want to just mention it to you guys. To manipulate the window, you can, first of all, I have to clear out the air that's there. To manipulate the window, I can just hit the window button. And you can change around the dimensions of your window. Window, again, is right here. You can change around the dimensions of your window. So, like, you can just, if I want 19 to show up on my screen, I just have to make the X value, the highest X value, something bigger than 19, right? Because you can plug in an X minimum, an X maximum, a Y minimum, a Y maximum. You can change the scale of the X and Y axes. But you can manipulate your window by hand, or I like to zoom out. Zoom 3. The tricky part here is people always wait for it to actually zoom out at this point. You have to hit enter. Then it will zoom out. The calculator is asking for a starting point. Now, here's the deal. Watch out again. So, not second table. Whoops. Second, calculate value of 19. It's still not on my screen. So let's zoom out again. Zoom 3, enter. Still waiting for those touch screen pinch to zoom calculators. It doesn't work yet.
What's it called?
Those are cost balance. That's true. And now we have it. Negative 241 beats per second. No. So this is not a good model for masses bigger than, well, wherever it goes into the negatives, right? So while it is a good model for our little snapshot of statistics that we have, is it a good model to use for interpretation, for extrapolation, I guess? That's a $10 word for extrapolation. There's another word for that too. Whatever. But this is not a good model for using big values like that. So Well, it's good for our little piece of information there. It's not good for the rest of it. Questions on that one before we move on? Okay, so that was 6. Let me just show the answers for 7. This one is the concert attendance problem. Oh, concerts. The good old days when we could go to concerts.
They did like Zoom classes, which like those would be no fun.
Yeah, really.
Just sit in your bedroom. They're so awkward too, and then the mic doesn't work very well.
Oh, that's a bummer. There's part A, the scatter plot. Again, it's showing you step-by-step directions on how to do it, but you get the idea. There's the scatter plot. And here's part B. Make sure you have the correct equation and the correct R value. If you don't have the correct equation and the correct R value, you probably plugged something in wrong. Okay, and then here's the graph. And there's part C. Again, you can just second calculate. You don't even have to zoom out or anything at that one. Second calculated value of 9. The Y value would be 180.37. Now, for statistical purposes, I'm okay if you give me a decimal of a person. You know, if you're interpreting something or if you're like saying this might happen in the future, it's not actually talking about like it's a concrete person. So I'm okay if you just give me a decimal value there, but if you didn't, if you just wanted to round to the nearest person, that'd be okay too. Okay, here's problems 9, 10, and 11. Just estimating the R value. I might even go a little lower with number 10, like maybe like a -0.3 or something like that, because that's pretty standard. Yeah.
Okay, so I took the numbers off of like our one guide notes.
Yeah.
Are these like technically would we still be accurate? Like even if we didn't get those exact numbers, I would still work.
Oh yeah, just estimate, just an estimate. Yeah. Okay. Just remember, the more scattered the points, the closer it gets towards 0. All right, and now let's talk about 15. The table below shows the length of the femur bone or leg bone and the humerus, an arm bone, the funny bone, for 5 fossil specimens of the Archaeopteryx, an extinct animal that had feathers and characteristics of a reptile. Okay, so we got femur length and as it relates to humerus length. So I'm going to go stat edit, and I'm going to clear out my lists. And let's plug in 38, 56, 59, 474, 41, 63, 70, 72, and 84. Okay. Looks like I've got 5 pieces of data, 38, 56, 59, 64, 74, 41, 63, 70, 72, 84. Good. Plugged in all correct. Let's go ahead and make my scatter plot. Clear out your y equals. I'm going to zoom 6, then zoom stat, and there's my scatter plot. Now it asks me to find the correlation coefficient and the line of best fit. So I got to go back out to my home screen, run my linear regression. Again, it's stat calc 4. So here is my linear regression. Ooh, R value of 0.994. That's pretty good. R value of 0.994, whatever. Y is equal to -3.6. Nope. Y is equal to 1.1969x minus 3.66. Sure. We're going to have to round up and up and up. Okay, so there's my equation. So now let's go and put it into my y equals. You go vars, statistics, EQ, and now I graph. And there's my line. Okay, what does the slope of this line mean? What does the slope of this line mean? Well, really, what does the slope of any line mean? The slope of any line is the change in the y value divided by the change in the x value. So the y value is the humerus length, right? So it's the change in humerus length for every 1 unit of change in femur length. So my slope here is saying for every 1.2 centimeters in change of humerus, I've got 1 centimeter in change of femur length. Okay, that's really what my slope is representing. Part C says use your equation to predict the femur length of that thing whose humerus is 50 centimeters. Now, the humerus length is the y value, correct? So I'm giving you a y value and asking you to find an x value. This is the harder of the two types here. To do this, I go into my y equals, and I plug in the y value into one of my y equals, like 50 here, right? 50 into my y2. I go to graph, and I hope that I see my horizontal line run through my diagonal line on this screen, so I don't have to zoom out. Oh, perfect. If you don't see the intersection point on the screen, zoom out a little bit, try to find it out, or zoom out and see if you can see it on the screen then. But I see it now, I don't have to worry about it, so I go second calculate, and now I want to choose the intersection point. Choice 5 is intersection. Now it's going to ask you again, first curve, second curve, and guess. First curve, second curve, guess. 44.832. So that's saying that if I somehow found a humerus with no femur bone, I could predict that the femur would be 44.83 centimeters. 44.83 centimeters. If the humerus was 50 centimeters, the femur should be about 44.83 centimeters. That's pretty precise. Too. Somewhere around there, give or take a little bit. How accurate do we think it is? Well, the number seems reasonable. It's not like a negative number. And in terms of my R value, that's pretty good. Yeah.
Okay, I was thinking of 10 and 11.
Okay, let me scroll back up. Oh, okay. So how do you determine whether it's positive or negative? By the slope of the line, right? So since I'm going downward, like since I'm generally going downward, right, I know that the slope is going to be negative. Now, are those dots pretty spread apart? So that means it's going to be somewhat closer to 0 than it is to 1. I mean, I might say like a negative 0.4, negative 0.3, okay? Since these are nice and close together, that's going to get closer to 1, right? And since it's a positive sloping line, it's going to be closer to the positive one rather than negative one. Right? If the dots are really close in the negative direction, you just call it like a negative point down rather than a positive point down. Does that make sense? Okay. All right. Questions on any part of the homework? Okay. So let's do this. Let's finish with the guided notes from Friday. What is it? Is it the femur in height, or is it the rainfall in Boston? Femur in height. Okay.
What is it with these people's femurs?
I don't know. Because it's so directly related to, other parts of the body, like your humerus length, your height. Yes. Does anybody need right now an extra one of these papers? Anybody lose it already? It is in the section 2.7 notes on Canvas, so if you wanted to check there, you could. But I will keep these now that it's past the street. I'm going to keep this right in there. All right. Well, my guide is nice. Okay. So, anthropologists can use the femur or thigh bone to estimate the height of a human being. So if you found, a femur detached from the rest of the body, I hope not, body, I guess you could predict the height. That's morbid.
Yeah, that's
morbid.
weird.
Or if you knew somebody's height, this is better. if you knew somebody's height, you could estimate their femur.
Why would I want to know
It's a little
someone's
less
femur length?
morbid. That one sounds a little
Right.
better.
Oh, you're 6'6", okay.
I bet your femur is about. Okay. All right. So this is a just a set of data with femur length and height. Let's go ahead and input this data into our calculator, shall we? Let's do this. We'll do this all together. Again, go stat and edit. Clear out anything that's there. Then let's input our data. Okay. Let's graph it. It doesn't tell us to do the scatter plot, but let's graph the scatter plot. Go into y equals, clear out everything that's there. Let's do a zoom 6 to get us back to our standard window, and let's do our zoom 9 to get our zoom, to get our scatter plot there. All right, and now we shall make our equation. We quit out of that, and let's run our linear regression. We go, questions? We good? Somebody tell me. I thought I heard somebody say Willow. Stat calc 4. Check your equation against mine. I'm going to bring this over here and write it on my screen here. Find the correlation coefficient R in the line of best fit. Okay. So the R value is 0.986. 0.986. So what does that tell us? That tells us that this is a positively correlated thing, right? This thing is positively correlated. This relationship is positively correlated. As one goes up, the other goes up. And as well, that this set of data is strongly modeled by this equation. Right? This equation is a pretty strong model for it. Y is equal to 2.9145 x plus 54.0415 as my y-intercept. All right. So there's my equation of the line of best fit. Now let's go ahead and put our equation on our scatter plot. Remember, to do that, you start in your y equals. You have to start in your y equals. Bars, statistics, EQ, enter. Enter. And now we graph. Okay, so there's my scatter plot with my line. Sweet. My next question says, is this the one that's different from you guys? What is your femur length? 41, is that the same thing? Uh-oh, yes.
My screen was just like
Blank? It's just
I
blank?
did trying to get the first thing and it keeps coming up.
Let me see. Like a graph? Oh, let's do zoom 6. Right, let's get it back to the standard convention and now do zoom. Yeah,
If you're like what, 4'11",
That's not there.
if
Oh,
you're like
not
9'4",
Turn that back on.
Oh.
Now let's
Very
do
big.
mine. There it is.
Tiny
Let's
bit.
go over Saturday. That's all we have.
Okay, for the line.
Here,
For the line, one more time. You go into your y equals. Right, it's blank, right? You go into your y equals and you click on bars. Go down to choice 5 is statistics. And then you go right twice for a regression equation. And now there's my line. Graph it. And there's my line. Does that make sense, Jack? Okay. Yours says 41 as well. One of mine is messed up. Yours says 41? Okay.
Yes.
All right, so a man's femur is 41 centimeters. Now, is the femur the x value or the y value? It's the x value, right? So perfect. I can go second calculate value. I don't have to do any of that funny business with the horizontal line coming across. I can say, okay, what's the y value when the x is 41? The y value is 173.5. Okay, so that means a man's femur is 41 centimeters. Predict a man's height. The height will be 173.54 centimeters, give or take. In feet? Well, that would be 1.73 meters. So I'm guessing like a little over 1.73 meters, a little over 5 feet.
That's a long piece.
That's the height.
Oh, I was looking at the wrong road.
Wait, femur is colossal.
The femur is gigantic.
The femur is larger than me.
All right, now is this one the same? 150. That's the weird one here. The 150. Okay. I don't know why I want to change this, but still. Okay, 150 centimeters. A man's height is 150 centimeters. Predict the man's femur length. All right, so now I'm given the y value and asked to find the x value. When I switch it around like that, well, now you have to go into your y equals and make your y2 150. And I hit graph and I hope I see the intersection points on my screen. Ah, perfect. There it is. Life is good. I don't have to zoom out at all or anything. I second calculate the intersection point. I hit enter 3 times, and the intersection point is right there. Right there. There it is. So we say that if the height is 150, the femur is 32.92 centimeters. Yes?
I'm not sure.
Uh-oh.
Either.
BRB. BRB.
Today's Mr. Laughing video is sponsored by Raid Shadow Legends.
You gotta go here.
Tell people
You go bars.
that if you're watching at home,
Watching at home, make sure to like and subscribe. Notification
yeah,
bell so
that's
never
right.
miss a Grant Laverick upload.
make sure you turn on
Four.
the bell.
Run to the left.
Like, I don't
And now, when you go into the video,
It's
now
another
you
big
can
break to
down.
shout out today's sponsor,
Today's shout out.
NordVPN.
We're special shout out to Caleb Yost, sponsored this video. Christian also sponsored as well.
Hey.
But then it lost money because everyone stopped watching it and disliked it.
Hey.
That was obnoxious. If you're watching this video, please dislike. Please hit the dislike button, unsubscribe, and turn on all notifications. For every dislike, Christian will have 1 detention. Please dislike this video.
People, again, to find the y value, or sorry, to find the x value given a y value, see Jack here. You got to put the 150 as one of your y equals, and then find the intersection point. That's where you plug in a y value into your y equals. Now, what is the last question on there tell us?
Find the man's height.
Find a why.
Man's femur is how long? 49 centimeters. Okay, so if I want to know what the height is, if the femur is 40, like somehow we found a femur with no person. It's 49 centimeters. Let's figure out how tall this person was. Second, calculate a value of 49. Uh-oh. What do? Zoom out.
I thought you just put in valid.
Right. Just put IPK on the answer blank on the top. That's acceptable. Second, calculate the value of, we said 49? There it is, 196. So when the femur length is 49, the height is 196.85. centimeters. So 1.96 meters. So that would be 1.96 times 3. I mean, it's not too bad. 5 foot, 5.8 feet. Not even 6 foot yet. Yeah.
How did you get it to zoom out?
What if you guys
Hit enter.
I zoom
Select
way
them out.
Oh,
Why do you zoom so far out? Because my mind.
Christian.
I find out
okay.
that like if you hit enter while it's graphic, you can pause it.
Yes, and
So I
then
just kept spamming enter, and every time I got done, if I hit enter,
All right,
it kept zooming out.
let's end the video. Any questions? Should I go to the order for the video?
make sure to dislike and unsubscribe.
Dislike? Can you dislike?
Yeah,
Is that possible?
Yeah,
I
that's
zoomed
how this
out to a
works.
solid
It's possible.
700.
So long, everybody.
Bye.
Thanks for tuning in.